Recently I've been doing a lot of sprinting and other similar high output, high wattage, high power riding on this bicycle connected to an indoor trainer. I had the suspicion that the bottom bracket mounted in the bicycle hereabouts has been sapping some of my precious effort and watts in mechanical friction that's completely unnecessary, and I want all of my power I can generate transmitted to the indoor trainer. Yes, it's meant for exercise, and no, having an effort just anywhere is not good enough. I want all of my effort registered and logged online. So I took it all apart. In this video I'll share with you what went on with the bottom bracket and what it takes to get this done, what tools and supplies I used to get this done. I will focus on the bottom bracket itself and the bearings inside the bottom bracket, which I chose to rebuild because I happened to be training in the Arctic, and with the COVID-19 lockdown in mid-November 2020, every other part that I would need is potentially months away in delivery. So in the meanwhile I need a bicycle, and no, I don't want a failed bearing on it. So I chose to rebuild it, and instead of a 5-minute bearing replacement, because this just threads into the bicycle just like so, and it's done once it's tightened. So instead of 5 minutes, this took me 4 or 5 hours to custom make tools and to rebuild the bearings. So I will in this video focus on the bearing, but will give you a big picture overview here what's involved in this thing. The bearing that failed on the drive side here, so that side of the bicycle, failed after 7,200 kilometers of riding. Now this is a gravel bike, so a fair amount of muck and mud and rain with dirt particles in it hit the bottom bracket and the bearings, and whether 7,200 kilometers, I don't know, it's about 6,000 miles, whether that's much or little, it really doesn't matter. The bearings failed. Whether they should last longer or not, that's up to discussion. Once it's gone, it's gone. They are inexpensive to replace, $30, and they are available. Press fit into a cup like this, and the cup, this threaded cup, just threads in place. You just saw it. It's very easy to install it if you have the part that you need. If you don't, like I don't, it's a rebuild. So let's take it from the top. How do we get to the bearing? I'll show you. It needs to start with crank arm removal, and in the crank arm, I'm gonna, in this video's description box below, I'm gonna include a link, Shimano's service manual on torque specifications and fitment geometry, where it's important, really look into it, okay? So on this split crank arm design, 2 bolts go into it, 2 pinch bolts, one this way, one the other way, and they are stainless steel bolts, and they are clean because I'm filming this out of sequence after everything has been cleaned, so they look like so. And they remove using a 5mm Allen key or hex key, and you need a torque wrench because the crank arm has a sticker on it, if you still have it, that it needs to be tightened to 12 to 14 Newton meters of torque by a torque wrench. So between the 2 pinch bolts there's a small plastic item. Please find it in the service manual, look it up and see how it should be orientated and what its function is. At the center of the pedal spindle, or at the crank arm here, there is a small plastic plug that looks like a trim item. It sits there, it's a black plug, and it needs a tool, for example like this, to be removed there. But it's not a trim item. It's really important for 2 reasons. This plastic plug threads into the threaded end of the spindle here, like so. And it's important not to cross-thread it. So it has 2 functions. It forces the crank arm on the spindle in this direction, and as it does so, it compresses the seals. That's one function. So there's one seal here that nobody notices or cares about too much, but this seal sits in that recess there, and it needs to be kind of intact and needs to be pushed back in place. I just finished cleaning everything here. The other seal is here. You can see it crossing the gap there. So this black item here is a seal, goes all around, lives in a recess here. It doesn't come out easily, but it can, and whatever, it needs to be cleaned up. So that's two seals to deal with, and this plastic plug compresses these seals as well as it preloads the bearing. So the bearing and the bottom bracket, both of them are compressed this way by forcing the pedal, or the crank arm with the pinch bolts and in them, and the plastic plug. The plastic plug is tightened, so the plastic plug compresses the seals as well as preloads these two bearings in the cups. Bearing preload is really important. It is to minimize rolling resistance, to minimize friction in a system, to minimize this mechanical friction, because I want all of my power registered on the indoor trainer, and they were so tight and so, yeah, I didn't like the bearings. After 7,200 kilometers they had too much grittiness in them. Well, one of them was not nearly seized but really bad, and the other was loosey-goosey, but at one point it had a catch in it, so now they are both even a little bit grinding-ish, whatever. It's not super smooth. Yeah, one side is more smooth than the other, yeah, because both of them are worn and have been removed and rebuilt, which is not ideal, but it is what it is. Part availability is a real problem, and no, I'm not waiting months just for... No, I will wait for the new parts. It's going to be months, and I'm not giving up on riding for months, and no, I'm not riding on failed bearings either. I'd rather ride on rebuilt bearings. So for however long it takes, I'm going to ride on these rebuilt bearings. So that's so that plug is preloading the bearing. Google it, look it up, really important. The bearings are mounted in a cup, and between the cup is a plastic spacer. So the cup just threads into the frame. Let's see, this is the left one. Okay, so this one threads in this way, and the other one threads in the other way around. So that means it threads in. Yeah, please don't cross thread it. It's gonna be painful. It should thread in just easily, just like so. Okay. Okay, I'm going to take it out now and talk about under rotation in just a sec. Welcome to engineering. No, we're not over engineering this, but under rotation is important. So what's that about? So this is not what you see when you take out the bottom bracket. You're not going to see a metal exposed edge there. It is covered up by a plastic item looking like this, so that's what you're going to see. And on it, the warning, do not disassemble. That's there for a reason. Really don't disassemble. It's not cost effective to rebuild these bearings. It is cost effective to replace the whole thing, the bearing with the cup, everything pressed, the bearing press fit into the cup, and replace it as is in 5 minutes. Let's see, does it say left on it? No, wrong one. Okay, so it really is 5 minutes to replace the cups, and once I have the new cups with the new bearings, it will be 5 minutes to just replace the cups, and away I go. But the bearing rebuild took me 5 hours here, by including custom making tools that I don't have. So what you're gonna see is this plastic trim item, and I just removed it with a putty knife like so. You can see the edge is a little bit chewed up there. That's fine, the edge is not important, although this whole surface here is keeping rain and muck and dirt out from getting to the bearing. The bearing's inner race, which is an exposed metal surface, so that shouldn't be rusting. It should be packed with grease. So this plastic component is important. Its edge is not important, but its diameter and thickness is important, that it be not cracked ideally. So how is this important? So this is a snap. This snap fits into the inner race of this bearing, and it's also tight around. It's not gonna fit over this plastic plug. It's also tight on the spindle, like so. Okay, and it's about here. Okay, of course it's the other way around. Okay, in this case, so if I want it there, it's gonna be there. Okay, on this side, in this cup here, on this side, roughly there. So it needs to be fitting tight enough so when the spindle rotates, this plastic trim item needs to rotate with it. This plastic trim item must have ideally exactly the same RPM as the spindle, and this one ideally has exact same RPM as the inner race on the bearing. If they don't, if this one of course is spinning faster than this one and the two of them slip here, and I'm just holding this one on, if this one slips, that means that the bearing inner race will have a slower rotation than the spindle does. This is extra friction here between the plastic trim and the spindle. Now the friction and the rolling and the rotation needs to happen inside the bearing, not here. Okay, so if this trim item is seized on or gets so full with sand and dirt and whatever that it gets compacted into place and the bearing under rotates, that means that this is slipping. It's unnecessary friction at the wrong place. It's sapping major amount of wattage out of anybody's efforts. So that's why it needs to be taken out and periodically cleaned, or the whole cup replaced, the whole bottom bracket with the two cups and the spacers and these trim pieces of plastic pressed in place. Now I'm going to put these back in place, and I'm going to put grease underneath, and because even though this is an indoor trainer, I will go outside eventually with it. The bottom bracket removes with a tool that fits the serrations on the outside of this, so you could remove it with a pipe wrench. Really don't recommend pipe wrench. It needs to be the proper tool for it. So, and one side spins one way, the other side spins the other way. So that's basically the overview of the components. I think I mentioned using this, a putty knife, for some of the work. For some of the seals, there are seals, an outer seal and an inner seal there, as well as two seals. One here at both ends of actually the crank arm to spindle, same crank arm to spindle. There are two seals there, so I use tweezers of all shapes and sizes, especially these two are my favorite, and I'm going to use grease. It's not a high-tech super bearing grade grease, it's just something that's widely available, multi-purpose, and more importantly it's an NLGI grade number 2 grease, so it's a softy grease. It will work at high temperatures, but high temperatures is, I can do on a sprint maybe 125 RPMs, 135 if I'm really giving it a go, but most often it's 110 to 120 RPMs, so that would be the highest rotation speed, highest RPM I get. At those speeds and at those loads, this is not going to go liquid, it's not going to run out of the bearing at any point, but it's a soft enough grease so it's so the bearing balls are not cutting through lard all the time. It's a soft grease. I'm using that. So let's head over to the shop and I'll tell you the rest of the story, what happened with this bottom bracket and what's involved in rebuilding the bearings. It is tedious, to say the least. You could also call it miserable. So eat, go to the washroom and get ready for hours of misery. Hey everyone, I gotta wear a face mask because I'm at a public place. This is not my garage door behind me. But more importantly to my story, on the bench I've got here a failed Ultegra bottom bracket, and this one here is on this coil rod ready to be taken apart. So in this video I'll show you what's wrong with it and what are my options right here in the Arctic. Let me just put the phone somewhere here. So parts are unavailable, inaccessible, and they take 6 weeks to get here. So replacement parts are out of the option. What's wrong with this one? It's impossible to hear it, but it is catching at one point. It's not smooth. And this one, the worst of the two, is very nearly seized up. So it's just very tight. So what I have here on this coil rod, and this is just some piece of garbage that I found in the other shop there. I've got two sockets that fit. So here is the bottom bracket, and this socket fits there to push out the bearing by the inner race. This one is holding it by the rim here so that the bearing can move forward, hopefully. Well, that's the theory. And I found these nuts or whatever these are in the other shop. That's all there is to it. So what I'm gonna do is rotate the two wrenches. Sorry, the other way around, of course. So what do we have here once the bearing is pressed out of the cup? So this is still intact, and this is what I took apart. So we have here a cup, an empty cup from which the bearing came out. Then we have two pieces of seals, one larger, how do I do this? A larger seal and a smaller seal. And we have this bearing that's got this shape. This bearing is absolutely unmarked, unidentified or unidentifiable, untraceable. This is what Shimano puts into this Ultegra grade. There is the part number, Ultegra grade bottom bracket, which is absolutely unbelievable. So all the grease has been rinsed out and used compressed air to clean out the bearing. So now it's reasonably clean, and now you can see rotation. I can still feel that it's catching here and there. The bearing re-greased, and then once it's in place, then this seal goes on it. So I'm going to be spending some time with this. That's basically my only option here when parts are unavailable. So this was the easier bearing of the two, because this one has a different cup shape. In this one, the cup here has a lip, if you can see that. So I can't put any of these sockets through in a way that it would catch the inside of the inner raceway on the bearing. This one is too thin. Too thick. If I find just a touch thinner one, it's gonna just, I feel it's just gonna slide past through. So what do? This bearing needs to be tapped out from the outside with an appropriate tool. Here, 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 and here. Advanced 12 o'clock, 6 o'clock, 9 o'clock, 3 o'clock. Advanced out of the cup ever so evenly and slowly And again, this is not normal, this is not ideal at all, that the bearing be tapped out from its location, because once it is hit, what's gonna happen is that these bearing balls, that if the bearing is hit on its inner raceway, which is made of steel, but the bearing balls might break this plastic cage that hold the bearing balls in place. So if I crack in the removal process, if I crack this plastic bearing ball retaining cage, that's gonna be detrimental to the bearing as well. But is a broken cage possibly gonna be better than very nearly, this is the worst of the two, very nearly, this is basically seized for all practical purposes. Is it gonna be better off? I hope so, that's all I can say. So after all, the bearings did come out of the cups and they are intact, both cups and bearing, and that's nothing short of miraculous, given the fact that the bearings are made of such thin metal. They can split and break if they are hit with excessive force. So they are fine-ish, given the fact that they are worn and used, but at least they spin, and they've been cleaned repeatedly in clean lacquer thinner, so they are at least better than they were when we started. This one is more rattly and looser, but they are interference fit into the cup, and the outer raceway is gonna get compressed, so it's gonna be less rattly. However, it may very well be rattly as long as it's not seizing up and is not a source of great friction. I'll be just happy. And they are gonna get re-greased with this. I don't have any special whatever, this is just number 2 grease, and that's what's going into it. It's gonna get pressed in place, the grease will be pressed in place, and then the seals will be put into the cup. In this cup, the seal at the bottom actually never came out. You can see the fine rubber lip on it, and it did come out of this cup, and of course, so the seal has to go into the cup in this orientation with this rubber lip pointing towards the inner race of the bearing. So they are together in this geometric configuration, like so. I hope this makes sense. There, with this soft edge of the seal pointing to the inner raceway there. Okay, just like that. So that's how they should be inside the cup. Now the cup says do not disassemble. It says so on that nylon spacer that's between the crank spindle and the inner raceway. It says do not disassemble, and that's right. Yeah, this is a miserable amount of work and slow going, and these are fairly inexpensive to replace. Cup, seals, grease, bearing, everything inside. I don't know, $30, but like I said, I don't have that option, and they are really lightweight. They are super easy to ship, small items. So what I'm gonna do is repack it with grease. So put the seal in place, and I have here something that will work from the other shop. I have this standard 1.25 inch pipe or so, copper pipe. Could be tubing, I don't know, but it's just a little smaller in diameter than the outer race on the bearing, just like so. So that means it can drive the bearing in place by hitting the outer raceway only, without breaking this plastic cage in the bearing, of course. And the outside diameter of this copper pipe is such that it just fits into the cup without destroying, damaging, nicking or scratching the cup at all. So it's gonna be used for tapping this bearing in place like so. And over here I've got this vise here. This can be, it doesn't have to be tight there, it just has to catch the shoulders of the cup like so, and the bearing packed with grease with the seal in place can be driven like so with a tapping block. There's a tapping block so I don't hit the pipe directly either, but so fairly straightforward and yes, fairly time consuming. If this was any easier, I'll tell you, but it ain't. So welcome to my world of pain. Okay, I didn't drop it on the ground, it's still there by some miracle, so I don't have to re-clean it because the floor is dirty. Alright, so the seal goes in there with this rubber lip up, but it's not especially held solidly in place or held in place at all. So what do? I'm gonna check it before the bearing is tight against it. I'm gonna check it, make sure it is not out of place, because yeah, I see already it's kind of rotating out. I'm gonna grease up the sides of the cup so the outer race does not catch on it. Because if I break this cup, split it by unevenly advancing the bearing, then I do have to wait potentially weeks for a replacement part. I really don't want to do that. Now, replacement part should be coming, and what I did was fairly straightforward. So here is a completely dry bearing, and I have just the tiniest little hole on this grease tube. So I just went around once. I know it's not quite against the bearing balls, but it's gonna work, and it didn't even go around once, so I just force it into the tiny spaces around the balls, the bearing balls, between the bearing ball and the nylon cup. So, and then this needs to be spread out evenly, and for that all I've got is this super height, I guess. Yeah, that's what I would have probably that's what I used to do when I was a kid with little toy cars. There we go, same idea, just spread it out evenly. It's coming along, and ideally when it's done I should see the grease coming out on this side of the spaces around the bearing balls. I will grease it on this side as well. Now, too much grease is technically gonna make you slower, so don't overdo it. Let's see what we can do here. I am gonna use this copper pipe for driving it forward. I'm just seating it in, make sure it's even, using this really soft tapping block, softwood. Yeah, it's not going really evenly. It's about a millimeter higher on that side. So I'm gonna switch to this one. And even rotate it so there is support directly underneath the portion or part that I want to hit. That's more like it. It's going in, all right. It's going in evenly, very important. So now the outer raceway is just about flush with the rim of this cup, everywhere evenly. So I really want to take my time here. and tap it just a little bit at a time, seriously checking it as I go along. Okay, now it went in on this side a little more than on this side, about 0.5 millimeter more. So I'm checking it again. Okay, looking even, looking nice. Okay. Now all of a sudden it just was one tap and it sank in 2 millimeters there and only 1 millimeter here on this side. So I'm going to rotate it so I can hit it here directly above the jaws on the vise. Good. And the taps are not huge either, or not hugely powerful. Checking the seal on the inside. So far the seal is very easy to move around. It has like a 3 millimeter, an 1/8 of an inch of a gap. So I got ways to go, and just really lightly, one tap, check it. If there's a little fiber textile from my garments or a hair or something from wherever, I want to get rid of it. I don't want to enclose any foreign material, any metal sliver or flake coming off this copper pipe. Here on the side where I do hit it there, so some of these flakes of copper do end up, yeah. So I'm gonna start filing it on this side. I'm gonna stop hitting it. That's how it's going, slowly. All right, last little taps here. That's solid. Okay, doesn't need any more banging and beating. Let's see how this one sits. So what's important about seating the bearing is that its outer race be exactly the same distance away from the lip of the cup in this direction down. You don't have to measure it down. The cup is made in a way that there's space for the seal and space for the bearing. So have a look at this cup here, and I'll show you how this outer raceway is going to interact with the seal. So the outer raceway is going to slide along the edge of the cup here, and will compress the seal that much, just a little bit, just in front of the screwdriver blade. You can see the seal being compressed, and the outer raceway will hit this shoulder here, that. So it needs to bottom out all the way there, and in that position it will compress the seal everywhere evenly, that much. This is a bit of a source of friction, but and this seal could be removed and omitted if this is an indoor bicycle and go a tiny bit faster, but it's yeah, I'm not too worried about it. So that's how the seal works with this shoulder. So it's gonna get compressed, the seal is gonna get compressed by the inner raceway, and the outer raceway is gonna be tight against this shoulder here. So the seal is slightly compressed when the bearing is evenly seated, and it's really important that the bearing be evenly seated, because if it's not, then it's sitting skewed, and it should be perfectly perpendicular to the direction of the spindle. So the crank spindle goes through there, and if the bearing is at an angle to it, it's just going to be additional source of friction. And the point of having an anti-friction bearing is to not have extra friction. Yeah, I put a little more grease on it, and I can put the outer seal in place with some extra grease. I'm gonna put him in there and then just press it in place, just like so. Maybe with the edge of the screwdriver, like so. Press it in place. It's got a metal backing, so it can be pushed down, and that's that. I've got the seal greased up enough, and I can just press it in place ever so gently, and I'm using this screwdriver just to pop it in place, just like so. there. Needs very little force. And as it is a metal-backed seal, it's yeah, the idea is not to bend it out of shape, and then just press down on it evenly everywhere. It's in place, and the lips of the seal is in the correct position. That's important, that the edges be not folded under or curled up or wrinkled or whatever. There. Alright, let's play with it. That's good. Let's play with it this way. Yeah, so how's the product? It's at least not seized up. It's been cleaned, so it's as little friction. Okay, it's not, it doesn't spin once it's compressed by the cup and the two seals and the grease provide a little friction to it. It's not it's not spinning that freely anymore, even if it's worn bearing. And being worn in this case, it's to its advantage. But I'm just checking the inner seal, looking perfect. Alright, it's good to go for reinstall.